Good evening, everyone. We can wait for some few seconds. Then we can start a question answers MCQ on exploring the magnets, class 6, CBSE. I'm waiting for everyone. Yes, I'm waiting for everyone. Give me a few seconds, then we can start a question answer session on the exploring magnets. Okay? Okay. Hello everyone. Good evening. Okay. So we are doing chapter exploring magnets, or according to old syllabus, fun with magnets. Question answers. We are revising this chapter. Okay. We can start with MCQ. So first is there the tendency to lose magnetism and magnetic properties is called what? Okay, whenever we are hitting, we are beating them, okay, then magnet is what started losing its properties, and that process of losing the magnetism is called as a demagnetize process. Okay, next is what is the magnetic force. So what do you mean by magnetic force? So magnetic force exerted by the magnet on the magnetic material in its magnetic field is called as a magnetic force. Okay, means suppose we have certain area, there is a magnetic field, and any object we are keeping in that field, then force is exerted on that object, and that object is get attracted towards it. That is nothing but the magnetic force. Then what will happen if a magnet is heated? Okay, what will happen if the magnet is heated? The what will happen, it loses its properties. Whenever we are beating them, hitting the magnets, then they are losing their magnetic properties. Getting this? So next question, how will you convert an iron nail into magnet? So how can you convert this iron nail into bar magnet? We know that bar magnet contains two pole, north and south. Okay, and when you are suspended freely, then it shows the north and south direction. But here iron nail is there, and that iron nail we have to convert it into magnet. So how can we do this? So here actually if we have a iron nail with us, okay, so keep that iron nail on the table, okay, and take a bar magnet and you can drag one end of the bar magnet over the iron nail, okay, from uh, from one end of the other. So this process if you are repeating again, then that nail is what acting as a bar magnet. So what we have to do here, we have to keep a nail on the table, and if you hold the bar magnet near to it, so one end you can, bar magnet end you can hold it at the one end of the nail, and you can just bar magnet over the iron nail from another end. Then this process if you are repeating, then that is gets converted into the magnet, that iron nail is converted into magnet. So what are the uses of the magnet? So magnets are used in the magnetic compass as well as they are using in electric motors. Okay. So next question, what are the important properties of the magnet? So very important properties of the magnet. So magnet always shows the south and north direction. Okay, and they can attract the objects made up of nickel, cobalt, and iron. Can you getting this? So always magnets are showing south and north direction, and they always attracts the objects which are made up of iron, nickel, and cobalt. Getting this? So now next question is that what are the attractive and directive properties of the magnet? Explain. Okay, attractive and directive properties means what? The attract means they can attract the substances like iron, cobalt, nickel when we brought near to it. Okay, this property of a magnet is called as what? Attracting property. Means it always attracts the materials which are made up of cobalt, nickel, and iron. And what are the directive properties? Then whenever you are suspending the bar magnet freely, okay, with the support, then it always aligns the geographic north and south direction, and then it comes to the rest, and it always gives the south and north direction. Okay, that are known as a directive property. Attractive means we are explaining about the attraction, directive means we are explaining about the directions. Okay, these are the two properties the magnet contains. Understood? So now, why does the freely suspended magnet always align itself in the north south direction? Can you think about this answer? Why does the freely suspended bar magnet or freely suspended magnet always align itself in the north south direction? Okay, so earth is what? A huge bar magnet, and also earth is a huge bar magnet with poles. South and north poles are there at its ends, and the north pole freely suspended magnet points towards the geographical north, and it is attracted by the earth's magnetic south pole. Okay, and south pole of the freely suspended bar magnet, it is pointing towards the south pole of the geographic area, and it is attracted by the earth's north pole. Okay, hence the freely suspended magnet is always align itself in the north south direction. Can you getting this? Now here the next question is that you are given an iron strip. How will you convert that into magnet? Iron strip is given, and that we have to convert it into the magnet. So again, this iron strip you have to take it and keep it on the table, and place one end of the bar magnet near to the one of the edge of the iron strip. Okay, without lifting the bar magnet, move along with the length of the strip till you reach to the other end. Then lift the bar magnet and bring it poles to the same point, then strip from where you began. Okay, repeat this process 30 to 40 minutes, then that iron strip is what? Behaving like a magnet. So here iron nail is converted into magnet. Now iron strip is also converted into the magnet. So procedure will remain same. Okay, we have to, whatever the iron things are given, that we have to keep it on the table. Bring one bar magnet near to one of hold it near to one of its end, and you can, without holding up, you can just drag to the another end. So this process, then again you can lift up and again take back to the again original position. For this process you can do it for 30 to 40 times. Then that iron strip is get converted into a magnet. Can you getting this? So write an activity to show that freely suspended bar magnet always comes to north and south direction. Okay, so here what we have to write an activity which shows the bar magnet, whenever we are suspending in the air, it always shows the north and south direction. So here activity is there, that means we have to write what is the aim. Aim is the suspended bar magnet shows the north and south pole. Material required, we require bar magnet. Then thread, stand also we require. And then procedure, take a bar magnet, thread, tie the thread at its center and suspend it to the rigid support, okay, freely at the one of the end. Then rotate slowly and note down your observation, and then it will become a rest. So then observation is what? Magnet is always, whenever we are suspending in the atmosphere, then it always shows the north and south direction. Okay, so here always conclusion is that they are always pointing north and south direction when they are at rest condition. Getting this? So now they are asking one question here: what are the magnetic materials, or what are the magnetic substances? Okay, so material which are attracted by the magnet, okay, materials which are attracted by the magnet is called as a magnetic material. Okay, and what are the non-magnetic materials? The substances which are not attracted by the magnets are called as a non-magnetic material. So can we give an example of non-magnetic substances? Like rubber we have, cotton, plastic, wood, button, cloth. These all are what? A magnetic, non-magnetic substances. Okay, and sometimes means they ask the question in MCQ, name the first magnet. So first magnet is nothing but what? Lodestone. Okay, the first stone is what? Lodestone. First magnet is nothing but lodestone. What do we mean by lodestone? Then lodestone is a type of iron and it bears the properties of a magnet. It is what? Actually iron and it bears the properties of the magnet. Can you getting? So here some materials are given. From that we have to define whether they are magnetic or non-magnetic material. If we take a key is made up of iron, then this is a magnetic material because it is attracted by the magnet. Then wood, it is not attracted, so it is a non-magnetic. Glass is also non-magnetic. Alpine, okay, alpine is also magnetic material. Chalk is non-magnetic material. Pencil, non-magnetic material. Okay, then fork is also magnetic material. Nail, non-magnetic material. Cup of tea, non-magnetic material. Book, non-magnetic material. Rubber is also non-magnetic. Fork magnetic, and needle is also magnetic material. Getting this? So these are the examples of some magnetic and non-magnetic material. Now what are the properties of the magnet? So here properties of the magnet we discuss. Whenever iron is there near to the magnet, it always attracts the iron. It always gives the north and south pole, and it always itself align in the same direction, left to rotate or freely rotate towards the left, and it is composed of oxides of the iron Fe3O4. Getting this? So here we have some other questions also. Okay, how to store the bar magnet and all. So bar magnet that we all discuss by in the next session. Okay, thank you for joining.